Okay, this is day 3, unit 3, and this is chapter 7.1, 7.2, graphing. The objectives are listed in your slide pack for today. So the first thing I want to talk about is ordered pairs. If we lay a line horizontally on graph paper, we could call that the x-axis. And then if we lay a line vertically that intersects that, we could call that the y-axis. The point where those lines intersect is called the origin. That's like our 0 point. It's 0x and 0y. So from the 0 point, horizontally, points to the right are positive and points to the left are negative. Just as you see here, positive 5 is to the right of the origin, negative 5 is to the left of the origin along the x-axis. Along the y-axis, positive points are up and negative points are down along the y-axis from the origin. And that divides our graph paper into 4 quadrants labeled quadrant 1, 2, 3, and 4. And so that goes counterclockwise from the top right quadrant, which is a little bit different than people usually number things, but that's quadrant 1, 2, 3, and 4. So ordered pairs of points have a particular value of x and a particular value of y. And what I want you to realize is the first number in the pair is called the x-coordinate, and it denotes which way you move horizontally. And the second number in the pair is called the y-coordinate, and it denotes which way you move vertically. So for example, 3, negative 5. The 3 is positive, so from the origin, which is where I always begin, I move 3 places to the right. That's the x value. It's positive 3. And I move 5 places down because that is a negative 5. So that point is represented by the coordinates x equal 3, y equal negative 5, which we denote as writing parentheses 3, comma, negative 5. So that's an ordered pair. Now, these are graphics. I mean, this is a graph, so we're going to be able to graph solutions for this. Okay, plot the point A equals negative 3, 5. Well, negative 3 means along the x-axis I need to move to the left 3 places. So there is negative 3. That's along the x-axis. And 5 is along the y-axis, and that's positive. So I need to move 5 places positive. There is point A with the coordinates of negative 3, 5. So I think that you're probably able to do this. I will do one more. B. B is at the coordinate 2, negative 4. So the point 2 is to the right 2. That's positive. And then I need to go down 1, 2, 3, 4 places along the y-axis. So positive 2, or to the right 2. And the y value is negative 4. There's point B. So I have graphed point B of 2, negative 4. Okay, so when we're graphing equations, there's a relationship between the quantity x and y. Y equals 4 minus x squared. We can find these values of x and y mathematically, and we can find them graphically. And whichever way we find them, they're called the solution of the equation. Now, the solution of our equation is an ordered pair of real numbers that make the equation 2. It's also the set of all points whose coordinates graphically satisfy the equation. So we have 2 ways to find solutions, mathematically and graphically. So graphing by plotting points. Here's our equation. Y equals negative x squared plus 2. Y equals negative x squared plus 2. So I'm going to graph values of x between negative 3 and positive 3. So that means, what is the value of y if x is negative 3 and the formula said negative x squared plus 2? So y is equal to the negative of 3 squared, which is, negative 3 squared, which is 9. So y is equal to negative 9 plus 2, which is negative 7. So when x is negative 3, y is equal to negative 7. Now, I would like you to pause this presentation and solve the rest of these, and then I will tell you the answer. Okay, when x is negative 2, y is negative 2. When x is negative 1, y is 1. When x is 0, y is 2. When x is 1, y is 1. When x is 2, y is negative 2. And when x is 3, y is negative 7. So now that we have found these, I'll just do one for you to make sure you're on the right track. We have the equation y equals negative x squared plus 2. I'm going to choose to substitute in negative 2 for x. So negative 2 quantity squared is 4, but I still have the negative that was out front. So that's the negative of a 4, which would be negative 4 plus 2, which yields negative 2. Okay, what I'd like you to do now is plot these points. And pause this presentation, then when you're done, I'll show you the answer. Okay, the points that I have are negative 3 along the x-axis, that's to the left 3 places, and then I need to go down negative 7 places. So there's my first point, negative 3, 7. Negative 2 means to the left 2 places on the x-axis and down 2 places on the y-axis. That's the point, negative 2, negative 2. Negative 1, 1 to the left 1 and up 1. 0, 2 means neither left nor right, but up 2 places. Positive 1, 1 to the right 1, up 1. Positive 2, negative 2 to the right 2, down 2 or negative 2, and then 3, negative 7. There is our graph of the solution of this equation. And so this is a parabola, and when you have a second degree equation, there are two solutions for x. Graphically, there are two values of x for this equation. So we have an ordered pair, two of them actually, that satisfy this equation. Now, the next page asks you, which of your graphs match? Well, it should have been this one. That's what our graph on the previous page looked like. Let's try another one. Graph the following equation, y equals 2x minus 4. Again, we're going to have a range of x from negative 3 to positive 3. So this equation, y equals 2x minus 4, I'm going to start with negative 3 substituted in for x. So negative 6 minus 4 is negative 10. That's the first value. And again, I would like you to complete this table. So pause this presentation, complete the table. Here are the answers. Negative 3, negative 10, negative 2, negative 8, negative 1, negative 6, 0, negative 4, 1, negative 2, 2, 0, and 3, negative 2. So the next step is to graph these. Oops, and I think I have a problem here. This was 0, positive 2. My mistake. So I would like you to pause this presentation and go ahead and graph these. Okay, you're back. So I'm working on graphing negative 3, negative 10, and there is the value of negative 3, negative 10. And then I want negative 2, negative 8, negative 1, negative 6, 0, negative 4, 1, negative 2, 2, 0, and 3, positive 2. Okay, there is our value, and so that is a line. And this just has one solution, one ordered pair that makes that, or one place, I should say, where we cross the x-axis and one place where we cross the y-axis. So the next question is, which of these graphs best matches yours? And of course, that is graph number 1. Okay, we have solved both of these equations graphically by substituting our numbers in and plotting points. Now let's talk about what a function is and defining functions. So if an equation is in two variables and it yields precisely one value of y for a value of x. We say y is a function of x. What that means is there's a one-on-one correspondence with there. And we write this as y is a function of x. And that means the variable y depends on what x is. And let's go back to our previous slide. We had the function y is equal to 2x minus 4. So that was a function of x. And so that could be read as the function of y, the function of x. I'm going to skip that for now. Just hold on to the thought, y equals f of x. And so the function of x, or y, is equal to whatever our equation of the line was. And so the last example that we had done, we had said y was 2x minus 4. So f of x is equal to 2x minus 4. Those two are the same thing. The function of x is equal to 2x minus 4. Or there's one value of y for an x when substituted into the equation 2x minus 4. So when you see problems written in function notation, you can just think of the f of x part as y. So find f from each given value of x. Now remember, we're thinking of this as y is equal to 3x squared plus 4x minus 2 when x is equal to 2. That's what f of 2 means. So when x is equal to 2, 2 squared is 4 plus 4 times 2 minus 2. So when f is equal to 2, it would be 12 plus 8 minus 2. So f at 2 is equal to 18. So I'd like you to do the next one. Okay, the answer for the next one, f at -1 is equal to 3 times -1 squared, which is positive 1. That's what I did there. Plus 4 times -1 minus 2. So that's 3 plus a -4 minus 2 is equal to -3. So f at -1 is equal to -3. Okay. A vertical line test. A vertical line intersects a graph in more than one point, then we do not have a one-on-one correspondence. And here's the deal. If I draw this vertical line and I think about moving this line to the right, when I get to this point, this line intersects the graph in 2 points. That means when x is a particular value, there are 2 solutions of y, and there's not a one-on-one correspondence. A one-on-one correspondence defines a function. And so to have a function, there's only one y for each x. And that's not true in situation A. And we can use the vertical line test to identify graphs in which y is a function of x. So if I think of a vertical line and I move it to the right and to the right and to the right, every time I move that line, there is only one place that the graph that has been drawn crosses my vertical line. It's these points. So for every x, there's only one associated y. The same thing with C. For every x, there's only one associated y point. But look at here what happens with my vertical line test on case D. There's 2 points again. For every x that is greater than 0, there are 2 solutions for y. So a vertical line test will define a function, and the definition of a function is there's only one y for each value of x. So you can use the vertical line test to determine if things are functions or not. Okay. Function notation. given f of x is equal to negative x squared, find f at negative 3. Go ahead and pause this presentation, and the value that you should get, f at negative 3 is equal to negative 9. Remember, this negative is outside. Negative 3 squared is positive 9, but we have the negative of that value, which is negative 9. So f of negative 3 is equal to negative 9. Now, I think I'm going to skip the next functional notation, but I think we should do the last one. So I'm given two functions here. I'm given f of x, and I'm given g of x. And I want to find g of 2 minus f at negative 1. So to work this, the first thing I need to do is find f at negative 1. So f at negative 1 means substitute negative 1 in for x, and that gives me negative 2. Now I'm going to find g at 2, and that means substitute 2 in for the value of x in the g function. So negative 2 times 2 squared, that's going to be negative 2 times 4, so that's negative 8. So that's the value of g at 2. And the last thing I was asked to find was g at negative 2, whose value is negative 8, minus the value of f at negative 1, whose value was negative 2. So negative 8 plus a positive 2 is a negative 6. I have found g of 2 minus f at negative 1. Okay. Graphing using intercepts. All equations of the form ax plus by equals c are straight lines as long as a and b are not both 0. That's called a linear equation in two variables. And the graphs will cross the x and the y-axis. The x-intercept is where the graph crosses the x-axis. That means when y is equal to 0. In order to cross the x-axis, and the x-axis is a horizontal axis, like this point 3, 0, in order to cross that point, the y value is 0. And likewise, the y-intercept is where the graph crosses the y-axis, and that's when the x value is 0. So just remember it's the opposite. The x-intercept is when y is 0. The y-intercept is when x is 0. And so graphing using intercepts, that's a quick and easy way to graph. So find the x-intercept of the function 3x plus 2y equals 6. So in order to solve this, we need to have it in the form ax plus by equals c. So I'm going to subtract 2y from both sides because I'm going for the form ax plus by equals c. So I'll subtract 2y from both sides. That's 3x minus 2y is equal to 6, and I'll write that as plus a negative. So now I have it in the form ax plus by equals c. And I want to know the x-intercept. Well, the x-intercept is when y is equal to 0. So I'm going to substitute y being 0. So 3x plus 0 is equal to 6. So x is equal to 2. So when y is 0, x is 2. That's an ordered pair that's on the graph. Now, truth be told, I don't always solve for this form. That's what your instructions say to do. I'll try and warn you if there's some sticklers on the homework. I've not had a chance to do your homework yet, but I'll sort through it and see if there's something that might trip you up. Okay. The next one, find the x-intercept of the function 3x equals 2y plus 6. Well, the y-intercept is when x is equal to 0. So substituting x being 0, I'm I'm going to subtract 6 from both sides. Y is equal to negative 3. So when x is 0, y is negative 3. That's the y-intercept. So graphing using intercepts. So graph 3x plus 2y equals 6 by finding the intercepts. Well, first find the x-intercept by letting y equal 0. So 3x plus 0 equals 6. 3x equals 6. X equals 2. Y equals 0. So I'm going to plot that. X equals 2. Y equals 0. There's that point. Now find the y-intercept by letting x be 0. And so now if x is 0, y is 3. So if x is 0, y is 3. There's our equation. Okay, next slide. The slope of a line is really just how steep the line is. And that steepness can be thought of as rise over run. And the steepness is really just the change in how steep it goes, the difference between the y values, as opposed to the difference between the x values. So some people like to abbreviate this with the Greek letter delta, which means change, the change of y over the change of x, signifying y2 minus y1 and x2 minus x1. Now, you need to know that positive slopes slant upwards to the right, and negative slopes slope downward. So what I've given you here is a positive slope. If I were to draw this going downward, that would be a negative slope. So here's an example. Find the slope of a line passing through the pair of points. So I want you to remember it's just change of y over change in x. So going ahead and writing down the values in the same order, if I start with the point 4 being the y value and x being negative 2, I need to keep those in the same order. So y minus y, 4 minus negative 1. And then I have to start with the x value associated with 4, which is negative 2, minus negative 3. That gives me a value or a slope of 5. So whatever you do, keep the one that you start with for the y is the one you should start with for the x. So here's one for you to do. Go ahead and do that, and then I'll put the answer up. So here's the answer. Change of y over change in x equals 9 minus 0 and 0 minus 3, which is 9 over negative 3, which is a slope of negative 3. So the slope-intercept form of the equation of a line has two parts. You got the slope of the line, and you got the y-intercept. Now, this is called the slope-intercept form of the equation of a line. It is always written as y equals some number m times x plus some number b. M is always the slope of the line. B is always the y-intercept of the graph, or where it crosses the y-intercept. So, y equals 2x minus 4. The slope is 2. The y-intercept is plus of negative 4. The y-intercept is negative 4 because you've got to have that plus sign in there. The slope of the second one is 1/2. The y-intercept is positive 2. So graphing the slope-intercept form of the line is really pretty easy. Now, this slide is in your slide pack so that you can read through, but I will show you. You always start with your y-intercept. From your y-intercept, you move your slope and draw your second point. Remember, slope always stands for rise over 1. So, let's look at an example. Y equals 2/3 x plus 3. So the slope, m, is 2/3, and the y-intercept is 3. Y-intercept is where it crosses the y-axis. So this graph crosses the y-axis at y equals 3. From that point, we rise to, because it's rise over run, we rise to, and we run 3 and place our second point. There's our line. Notice that line slopes upwards. It should have a positive slope, and m is a positive 2/3. So we have graphed that line. Next one is for you. What you will need to do is 2x plus 5y equals 0. Solve for y, and then graph it. Pause this presentation, please, and do that. Okay. Solving the equation for y should yield negative 2/5 x plus 0. Our y-intercept is 0. We slope down 2 over 5. And there is our equation of y. Okay, equations of horizontal and vertical lines. The graph y equal b is a horizontal line. Everything is at the value of b. So that's a horizontal line. The graph x equals a is a vertical line. Every x is that particular value. When you're talking about the slope of this vertical line, there is no slope. When you're talking about the slope of a horizontal line, there's a 0 slope. So graph these. Y equals negative 4 is what that should say. So if y is equal to negative 4, every value of y is negative 4. This is the vertical line at negative 4. X equal 3. Every value of x is equal to 3. This is a horizontal line. Okay, I am going to skip this question. It's been a plenty long lecture. Your homework assignment is my Math Lab Unit 3, Day 3.